we'll first talk about choice under uncertainty, okay, and we'll talk about exactly, if you want to take a decision whether you want to take a gamble or not, okay, or basically buy insurance or not, or basically if you want to compare two random variables, how you're going to take those decisions, okay, or basically if you want to model that kind of behavior, how to model that kind of behavior. Okay, is that fine? Okay, so so we already know that there is, we can always write utility as a function of consumption bundles, okay, but here we are not really writing utility as a function of consumption bundles. We want to write an expression for utility as a function of lotteries, okay, some random variables, okay, like for example, what is your satisfaction level associated with a lottery that gives you 0 with probability half and 100 with probability half, okay. That's a lottery, right? I mean, suppose I offer you this lottery that that you will get, I'll toss a coin, I toss a fair coin, okay, and if it's a heads, you'll get 100, and if it's a tails, you'll get 0. Okay, so that's a lottery. Okay, now if I ask you to compare this with, let's say, a certain amount, 25 rupees. Suppose I'll ask you whether you'll choose 25 rupees or you'll take this lottery. So I mean, that's an example. That depends, of course, on the person. Okay, so some people might choose a certain amount, 25 rupees over the lottery. Some people might choose the lottery over 25 rupees. Okay, so it totally depends on the person. Okay, fine. Okay, so I mean, do you understand? I mean, in many situations, these kind of situations arise where you have to make a comparison between lotteries. I mean, it's not about just basically a bundle versus bundle, but it's actually a lottery versus some other lottery. Okay, similarly, you can imagine a scenario where you are trying to get some insurance for buy some insurance to actually get rid of some kind of uncertainty that the future is offering. So basically, you already have a lottery and you want to sell it off. It's like, you want to actually in return buy some insurance. Like for example, there is a possibility that fire might burn your some property, okay, and then you might just go for fire insurance, okay, and in that case, in the event that fire indeed leads to, okay, fire indeed leads to this mishappening, you will get some amount from the insurance company in return. Okay, is this fine? So that's actually another example of a situation where you are actually trading off lottery. Is that fine? So of course you need to know exactly what should I buy, when should I buy, and what should I not buy, and so on and so forth. Okay, so we need to understand the preferences over these lotteries. Is that okay? Clear? Okay, so let us talk about that. Okay, so what I'll do is the following. I'll define two types of utility functions. The first function that I'll define, I'll call it a Bernoulli utility function. Okay, so this is a Bernoulli utility function. Okay, so Bernoulli utility function, I'll use small u to denote it. Okay, small u is Bernoulli utility function. It's a function from set of wealth levels. Okay, okay, set of wealth levels to R. Okay, so it's a function which will give you utility associated with different amounts of money. Is that clear? Okay, so let's say if you have 100 rupees, what is the satisfaction level associated with 100? This function will tell you that. Okay, if you have 200 rupees, what is the satisfaction level that is associated with 200 rupees? This function will tell you that. Okay, so you just have to plug in the amount of money that you have in this particular function that gives you the satisfaction level associated with that kind of money. Is that clear? Okay, but of course, we'll have this standard assumption, that utilities are non-decreasing in money. So the higher the money, the utility will never go down. I mean, it can go up or it can stay the same, but it will never come down. This is something that we'll assume. Now, this is a utility function uh, over wealth levels. Okay, but if you really think about it, in real life, what you face is you face lotteries, and lotteries is over different wealth levels. So there's a possibility that tomorrow, you might lose some money or you might gain some money. Okay, so you might be facing some choices that whether I want to buy some insurance against some loss or not, things like that. So basically, if you really think about it, you don't want to compare utility across wealths. You want to compare utility across lotteries of wealths. So you might face one lottery of over wealth and another lottery over the wealth levels. So you want to have some comparison so that you can say that, okay, this is something which I like more, this is something that I would prefer, and this is something that I don't prefer, and so on and so forth. Is that okay? Clear? Okay, so for that, of course there are multiple ways. So I'll go with something that is a standard way of modeling. I mean, I would say, like, this is the way in which we model it uh, more often than not. I mean, this is something that is used more in literature to model behavior over lotteries. Okay, and this is known as von Neumann Morgenstern utility function, VNM, expected utility function. Okay, and what is this VNM expected utility function? I'm going to use capital U to denote it. So this is small u, this is a utility function over wealth levels. Okay, this is capital U, this is a utility function over set of random variables on wealth levels. Okay, set of random variables or lotteries, it's the same thing. I'll just use these words interchangeably. Okay, set of random variables over R plus. Okay, R plus is basically set of possible wealth levels. Okay, set of non-negative random variables. You can say set of non-negative random variables to R. Okay, and this is how we define it. Okay, utility associated with lottery X. So capital X, remember we denote capital X by random variables. Okay, so utility associated with capital X is expectation of U of capital X. Now, X is a random variable. Small u is a utility function over wealth levels. So what you do is you transform it. Transform the wealth levels to utility levels using small u function. Okay, and then take the expected value of it. That's why we call it expected utility. Is that fine? Okay, so if you see, this is u. U is a function from R plus to R. Okay, X is a random variable. Okay, and that's a function from S to R plus in our case. Okay, so what you're doing is this: you are taking a composite function U of X. Okay, that's a composite function. Now this is going to give you kind of a lottery over the utilities. You can think of it as a lottery over the utilities. You just take the expected value of it. That's your capital UX. Is this fine? Okay, let me give you one example. I think that's going to make it clear. Okay, so I mean, just you know, this is just so you don't have to worry about it. Let's just think of some example. Okay, so let's move back to, you know, an experiment. Okay, so consider the following experiment. The experiment consists of tossing a fair coin. Okay, fine. So that's experiment. So what is the sample space? Head and tail. Okay, great. Fine. Okay, that's your sample space. Is that fine? Okay, and it's a fair coin, so probability of heads is half, probability of tails is half. Okay, now I'll consider the following random variable. Remember, random variable is a function from sample space to real line. Okay, so consider the following random variable x of h. So if it's a function from sample space to real line, the input will be an outcome from the sample space, and the outcome will be a number. Okay, so x of h is what? Is, let's say, 100. Okay, x of tail is 0. Okay, so basically I define a lottery, and lottery is as follows. I'll toss a coin. If heads come, I'll give you 100. If tails come, I'll give you nothing. Okay, so that's how I can write this lottery.
Yes.
Okay, now suppose we have an individual whose utility over the wealth levels is this. Ux is root x. Okay, ux is root x. So what we are going to do is the following. You know, of course, we can always find the expected value of this lottery. What is the expected value of this lottery? 50, right? Half into 100 plus half into 0. So instead of finding the expected value of the lottery, we find expected utility of the lottery, and that is the satisfaction level associated with the lottery. Now, what do you mean by expected utility? What you do is the following. You figure out what is the utility associated with this wealth level. What is the utility associated with 10? Okay, and what is the utility associated with this?
0.
0. Okay, and now instead of finding the expected value of the lottery, you find the expected utility of the lottery. So you know what, so basically, you know what you are doing is this. You have converted the lottery amounts that you are going to realize into the realized utility levels. Are you getting my point?
Yes.
Okay, so it's like a lottery over the utilities. These are utils. Okay, so you have a lottery over the utils. Now you figure out the expected value of this. That's expected utility. That's it. Is that okay? So what is the expected utility of x?
5.
Absolutely. Okay, and that is my definition of the utility associated with this lottery. Have you understood now?
Yes, sir.